presenter just yet, so it was coming in virtually. So we're going to go ahead and just move forward with the order of the program. I'm going to turn this over to Karen Moore. Karen is with the Florida Department of Environmental Protection, and Karen is going to moderate this session. So Karen, all yours, ma'am.
Thank you, Gene.
Recording in progress.
Okay, good afternoon, everyone. Good afternoon. I heard one good afternoon. we got to bring the energy, right? 3:30 afternoon, time to... Anyway, welcome to Session 3, General Recycling Session. And this afternoon, we're going to be talking about, or our speakers are going to be talking about some non-traditional recycling. We've heard all kinds of great information on plastic and glass recycling and policies and regulatory frameworks, but really excited to hear this afternoon's speakers. Do most of you realize that waste to energy counts towards the recycling goal in the state of Florida? That's something I don't know that many other states in the United States have, but waste to energy does count towards recycling in the state of Florida. So I'm excited to hear our first speaker today, Dave Robau, come up and talk about waste to energy. So welcome, Dave.
I get to go first. I got promoted. Cool. Awesome. Thank you so much. I certainly appreciate the opportunity. So thank you to SWIX for inviting me, giving me an opportunity to talk some trash with you guys. And thank you, Karen, for that introduction. So I'm Dave Robau. I'm the CEO and Chief Scientist for a company called National Energy. I'm going to talk a little bit about the industry as a whole. I'm going to provide you with some context. I'm going to talk specifically about how the military is looking at our waste material as a resource and looking at how it can play a role in energy security. So with that, we're going to jump right into it, and hopefully this clicker works. Maybe not. The big button, right? Rumor has it. Okay. So I've probably spent about 20 years as an environmental scientist, first doing a lot of what I call the bugs and bunnies work. So I started out as a wetland scientist looking at the biological resources side, and then the second half of my career was mainly on infrastructure and looking at building some resiliency around our infrastructure. And then right around the time of Operation Enduring Freedom in my Air Force capacity, I got asked to look at garbage. Why would the Air Force be interested in garbage? Well, it turns out that in conflict areas, the military is required to take all of its garbage, and because of host nation agreements, has to ship it to, typically on the back of a big C-5 or big C-130 aircraft. Actually, that's a C-130 in the image there, and then bring it back to sanitary landfill. You can't just deposit it in a landfill in, say, Afghanistan, and plus you really wouldn't want to. There's some security issues associated with that. So in the lead up to Operation Enduring Freedom and some of the conflicts in the Middle East, the CIA, of all agencies, was operating something called pit burns. And if you can imagine a big hole in the ground the size of this room, and everything that is generated in these, what we call AOR, in theater, goes into this pit burn, and we light it on fire. What could possibly go wrong? So lots of class action lawsuits with airmen having respiratory issues and neurological disorders because we're literally burning garbage. The Joint Chiefs of Staff put a cease and desist on all pit burn operations, came to where I was working at the Air Force Special Operations Command in Florida, and asked us to devise a system that could safely deposit garbage in this particular case. So I'll talk about that and kind of a case study, but that was my role as the garbologist for the Air Force, looking at ways to be able to use the inherent embodied energy in the waste stream and do something else with it. So for context, what a lot of us do, a lot of scientists and engineers, effectively what we do is we leverage technology to solve environmental challenges. And I'll talk through this a little bit, but in a nutshell, that is what we do. So let me give you some context before we go too much further, and just understand that energy fuels the military mission. And whether it's powering buildings to be able to run operations around the world, or whether it's fuel to provide, in the case of the Air Force, the flying mission, energy is really the lifeblood of the military. So there is a very strong correlation. We like to say energy security is national security. They're one and the same. So it wasn't until recently that the Department of Defense started to put a definition around energy security. Well, what is it exactly? Well, we started to see some language in the USC that talks specifically about energy security. And the Army took it one step further and actually put some parameters. So it wasn't enough just to secure your energy. It was about your critical infrastructure and being able to power that critical infrastructure, whatever it might be at any given installation. And in the case of the Army, it's for a 14-day period. So your air traffic controls, your tactical squadrons, your wastewater treatment plants, all critical infrastructure. So now we're starting to get a definition of what energy security is and what it means. So now, fast forward, when we start looking more closely at climate change and the impacts of energy security, and not getting into the politics of it. As a scientist, I try not to play politician, and I wish that the politicians would not play scientist. But really, at the end of the day, what it means to the military is when we start looking at these impacts of what we call billion-dollar weather and climate disasters. So in 2018, this graphic was put together by North Carolina State University, and regardless of where you are in the country, we have Black Flag days, which are days where the temperature is in the triple digits, and the Army can't run its training operations under Black Flag conditions. So it impacts troop readiness when you can't train your soldiers. We have floods in the middle part of the state at Offutt Air Force Base was completely flooded. Of course, closer to home in Panama City, Tyndall Air Force Base was the direct hit for a Category 5 hurricane, Hurricane Michael, decimated about 86% of all structures on that installation. So now that installation is going through a $5 billion renovation to what's referred to as the base of the future. But when you start looking at all of these impacts, and if you look historically, the greatest year, the single year where we had the most billion-dollar weather and climate disasters was last year. We had 22 of them. And you could see that regardless of where you are in the country, you are vulnerable to the impacts of climate change, whether it's sea level rise or forest fires. You know, out west, California, if you remember, used to have a fire season. Well, now it's all year. And it's just these impacts are more devastating as more people are moving and migrating to coastal communities. So the military, as you can understand, when an installation is impacted, I swear I'm clicking on this. When an installation is impacted, like Hurricane Michael did at Tyndall Air Force Base, you know, the Air Force doesn't pick up the phone and call Jake at State Farm, right? They're self-insured by taxpayers, and it's your tax dollars that are going into rebuilding these installations. Well, if you look at where these installations are located, they're in high-risk areas. So this is all something that, you know, the military has to contend with. So what that leads to is being able to provide on-site power generation. So the traditional model of energy delivery is out in the hinterlands. We're producing kilowatt hours that run through transmission distribution lines to get to this building to power this facility. Well, there's lots of potential for disruption through that supply chain. So the idea here is to be able to build energy microgrids where the energy is actually being used, and you cut down on a lot of those potential hazards from extreme weather events, which I'll cover here in a minute. So a microgrid, effectively, without getting into too much detail, you're basically just producing energy at the source where it's being used. And what that means is if there's an impact to the supply or the delivery of those electrons to the installation, you can provide some buffer through what we call distributed energy resources. So these distributed energy resources give us the ability to buffer against vulnerabilities in the distribution of energy, whether it's weather-related, whether it is a physical attack or a cyber attack on the electrical infrastructure. These energy microgrids give us an opportunity to serve as backup power. So now you can understand how the military is gravitating towards these energy microgrids, because it gives the military some flexibility to be able to provide the training requirements that are needed for the mission, in the case of the Air Force, to fly, fight, and win in airspace and cyberspace, as we like to say. So now we start to look at these microgrids as an opportunity to provide value, and whether it's environmental or whether you're trying to save money, or in this case, whether you're trying to provide another layer of reliability, this becomes an important construct to help sustain the military mission. And all the services are looking at energy microgrids to be able to fuel the mission. So even the Army took it one step further. You know, we were always looking at energy, we were always looking at water, but the Army went one step further and said, we want to include our waste stream to be able to, quote unquote, net zero our installations. So there's a few pilots that are looking at solid waste and how you can minimize the use of landfills and being able to use that material for another purpose. So that brings us to my favorite topic. My wife likes to say I have an unhealthy relationship with garbage, and I think she's right. When we take the kids to Orlando to come visit Mickey Mouse, I'm off on a landfill tour somewhere looking at something like this. And for some of you, you look at this and you say, well, that looks like an environmental liability. For others, you look at this and say, well, that looks like money. And they're all true, I suppose. For me, I look at this and I see this as an energy warehouse. I look at this as a battery. Being able to draw the energy that's in that waste stream and give it another purpose, whether we're extracting the methane from the decomposition of the organic matter, or using that material before it even goes to the landfill, through landfill diversion and some of these projects that I'll talk about here in a minute. So I'm going to give you a couple of case studies, some projects that I was very familiar with. This project is in California at Fort Hunter-Lingen, and this is an Army Reserve base. And this was a project that, if you think about how much waste a military installation generates, it's typically not a lot. It's not like the city of Orlando or another municipality. The waste streams are typically small. Some of these military installations may have 5,000 or 10,000 personnel and contractors, so they don't generate a tremendous amount of waste the way a small or medium-sized city would. But what was groundbreaking about this particular project is the Army had set out some requirements to be able to build a project that was diverting specifically municipal solid waste, and it was in line with some of the initiatives that the Army had put forward. And they had built this project using a technology, I won't go into the specifics, but it's a gasification project. So we're using the calorific value of that MSW waste stream and looking at ways to be able to convert that material, that chemical energy, if you will, into, in this particular case, they were looking at creating fuel, liquid fuel, like through a Fischer-Tropsch process, hot water, which is one of the byproducts, electricity, if that was what the installation needed. So what was significant about this project is not only was the installation diverting material from the waste stream, which is good, but we were also using it and then testing other waste streams like construction and demolition debris. A lot of military installations will generate a lot of C&D waste. So looking at other materials, because of this process, it allows itself, it lends itself to look at other feedstocks. And then I'll spend a couple of minutes talking about this particular project, and you're going to learn a little bit about a specific process called plasma gasification. I try and keep everything at kind of 10th grade science level, but But this was a project that I referenced in my introduction. This project was at Hurlburt Field, so we got permitted through FDEP on an RD&D permit. So we were basically, this was a true science experiment. We had never built this. We had some ideas of what would happen. We went over budget, we went over schedule. The nice thing about going over budget on federal projects is when you run out of money, you just call your congressman, send them up to Capitol Hill to bring you back $2 million, because this project was in fact over budget. In the real world, we really don't have that luxury, unfortunately. But as I mentioned, a lot of these installations, they don't generate a lot of waste. But the idea was, if we can build a facility using a plasma gasification technology, which I'll talk about, to be able to take all of the waste generated at Hurlburt Field. So this is in the panhandle of Florida, Okaloosa County, if you're familiar with that part of Florida. And the idea was we were going to build a system that had a 10-ton per day capacity. So we could take, again, all of the waste that's generated in the installation, run it through this system. Some people call this chemical recycling. Basically what's happening, you're subjecting the waste material to the intense heat of plasma. So we built a furnace, which is actually in that. Is there a laser pointer on here, maybe? Oops. Top one. That's what I did. Oh, I see. So that's pretty cool. So this is our furnace. So this is where all the magic happens, if you will. Inside of this furnace, it has a fire brick refractory because we're mimicking the conditions of the surface of the sun. So inside of that chamber, we're subjecting all of this material to about 10,000 degrees Celsius. So what happens when you subject material to that intense heat and pressure, the long chain carbon molecules will break apart, they'll disassociate, and we'll reformulate those into hydrogen and carbon monoxide, CO. So we take those two, we combine it, those are great vectors for energy, and effectively we're converting the chemical energy into mechanical energy, turning a turbine and producing electrical energy, which I'll talk about. So the idea was the system had to be portable. So if you notice these blue skids, everything was built on 17 skids. And the idea was we had to be able to take this apart, the whole project, put it on the back of a C5, fly it into Balad or wherever it needed to go into the world, put the whole thing back together in less than 4 days. So connecting these 17 modules so that if it had to go into the AOR, into the area of responsibility, wherever we had a conflict, we can now use this facility to handle all of the solid waste that's being generated. So we had a number of I'll call them issues, because that's what happens when you do science experiments. We take for granted light bulbs, but it took 1,000 different failed attempts to get us the light bulb. And that's effectively what we learned through this project is while we were able to produce process 100% of the waste that was generated at Hurlburt Field, literally 100% of it, it was at a really, really high cost, about $163 per ton. So when the prevailing tip fee is about $61, it's hard to make the business case for that. But again, this was first generation technology. I think the first microwave that was ever built was $5,000, and now you can pick one up at Target for like 80 bucks. So the idea is as the technologies mature and they develop further into their life cycle, the cost should go down through Boyle's law. So effectively, when we built this, like I said, it had to be modular. It had to be transportable. We were working with the Air Force had a budget of about $2.1 million. The whole project was about $7.4 million, and the Air Force contribution was $2.1. So at the time, we were spending $700,000 a year on tipping fees, literally just taking our garbage and trucking it to Jackson County and then paying the tip fee at the landfill. So from an ROI perspective, the Air Force had about a 3-year return on investment because a lot of these funds were coming from other sources, to include the Canadian government. The technology that we used was Canadian. So for those reasons, you know, the project was manageable because the Air Force was bringing a small part of it. So effectively, the way plasma gasification works is when you build these systems, they're designed to take pretty much anything you put into it. Now, we weren't certified to take, you know, nuclear waste or things like that, but we could take biological waste. In fact, we did a test run for 6 different waste streams. I think 3 are probably still classified, but it was basically medical waste, municipal waste, and some household type chemicals. And what we found was, through the process of plasma gasification, we could create that syngas that I talked about earlier, the carbon monoxide and the hydrogen. We would run that through, in this particular case, we used a Jahnbacher, which is basically an internal combustion engine like the one in your car. So we would run this syngas, much like you would put gasoline in your car. And then the excess power that was consumed, that we had a parasitic load on the actual equipment, and then the excess power would get exported to the grid. So on average, we had about 850 kilowatts per ton of garbage, if you want to kind of look for a way to equate that. So we had a volume reduction of about 99%. So 1%, I'm going to see if I can get this to work twice. Oh, look at that. So 1% was this slag material here. So what's interesting about this slag is environmentally it's inert. We found out that the Department of Energy uses slag to crystallize nuclear waste so that it doesn't leachate, it doesn't leach into the environment. The Navy had asked the Interpol, not Interpol, what's the agency that, MARPOL, sorry, Interpol's a different one altogether. MARPOL, who governs navigational waterways, if the Navy could use this slag material and dump it overboard, because the Navy was really interested in using plasma gasification for their vessels, and they do today. What's interesting about this slag, we talked in one of the sessions earlier, we also reached out to the Hinckley Center at the University of Florida, and they did strengthened materials testing on this slag material. And what we did at Hurlburt to kind of close the loop on that last 1%, we put it in asphalt projects, because the university came back and said, yeah, you can use this material as an aggregate, and you could substitute this with this glassy slag and use it for asphalt. We called it glassphalt. But the idea was we were able to put this back into the circular economy and be able to use that material. So for a brief time, Hurlburt Field was a net zero waste installation before it was even a term, which was kind of nice. And then we were able to extract metals, you know, just with eddy currents and magnets and things like that. So the byproducts, I'm going to start to wrap up here in a minute. The byproducts were electricity. So like I mentioned, we were trying to cover the parasitic load on the actual equipment, which is considerable. I mean, you're heating up material to 10,000 degrees Celsius, so it takes a lot of energy to do that. But it did have a net output that we were able to use on the installation for, you know, other critical infrastructure, putting the excess power on the grid. And what we found was that this was a really interesting use case, looking at taking garbage and providing what we call a waste-powered energy microgrid. So I talked in the beginning of the presentation about the importance of generating power where it's being used, you know, the distributed energy resource model. Well, here there's a way to take garbage that's already being generated on the installation and use it as a feedstock, and then be able to power critical infrastructure on the installation. So imagine if you're able to do that on a larger scale when you're dealing with 200,000 or 300,000 tons of waste per year, not just the 5,000 or 6,000 that we were working with at Hurlburt Field. So it became kind of interesting to be able to look at this and how could we extrapolate what we learned here and bring it to a larger city. So we're in conversations right now. We're actually under contract with the Air Force. I started National Energy about 5 or 6 years ago, and we're now under contract with the Air Force to look at what we call this waste-powered energy microgrid at some of the special operations facilities, 2 in Florida, MacDill Air Force Base down in the Hillsborough region, and then my old base at Hurlburt Field in Okaloosa County, and seeing if there's a way to kind of solve, they call it dual-use solutions, kind of solve 2 problems with 1 solution. In other words, the community is generating a large amount of garbage that's not bringing any value back to society because we're just putting it in the landfill and crossing our fingers and hoping that nothing happens, which is never the case. So oftentimes we're creating problems for our grandchildren. I like to say there's 2 kinds of landfills, the ones that leak and brand new landfills. So the idea is if we can take some of those materials and reuse them and bring them back into the circular economy, and in this case, enhancing the military mission, we see some opportunities there. So this waste-powered energy microgrid, we believe, can provide some of the energy resiliency that a community might need to buffer against extreme weather events, whatever it might be. In those zombie movies, everybody always goes to the military installation, as kind of the lighthouse. And being able to have power to that facility becomes critical, especially in a community where you're trying to keep citizens safe. And being able to use that as a backup power source that's both clean, renewable, and resilient. So we see these as some opportunities for some other projects. So I think in short, I think what we're trying to say is these waste-powered energy microgrids would give a community some resilience to be able to, what we call island, from the civilian grid in the event that there is some kind of an attack, whether it's physical or cyber or just weather-related down power lines and things like that. So the question that maybe we can kind of explore a little bit further after the panel is done, or maybe in the exhibit hall, if you come over, we can talk about this, is can we start mining landfills and being able to use that resource to generate power? So that's all I have. I'm going to turn it back over to you, and we'll go from there. Great, thank you.
Hey, Karen?
Yes.
We do have Brett online, so if we can go to him,
Okay.
and then Bob will hit you at the end. That way it works.
Okay. Well, thank you, Dave. Very interesting presentation. I'm sure we'll have lots of questions coming up. So are there any burning questions right now? If not, we'll go ahead and queue up our next presenter. Okay, so we'll go ahead and queue up our next presenter, which is Brett Whalen. He is a waste management specialist with Corporate Logistics, Lucid Motors. Do we have Brett online?
Might have got to hit the unmute button, I guess, don't we? That usually helps.
Go ahead and share your screen, Brett.
Yes, it says, I think you need to give access. You cannot start screen share while other participants are sharing. But I do think this is a good transition from energy security. One of the topics for me is going to be critical access to raw materials in the supply chain as it relates to EV manufacturing and having the materials to make the batteries that we all depend on in the future. And I think since we've seen this big shift recently by almost every major OEM, Bentley, Audi, GM, all saying that they have certain goals to make so much of their production electric in so many years, has created a greater demand, and with such, I think we'll see some other industries also kind of follow suit. make those transitions as well, and then it will actually kind of strengthen other aspects of recycling in a whole. So a little bit more about myself. My name is Brett. I have about 15 years of diverse recycling experience. So I've worked for waste haulers, for private haulers as the liaison between the hauler and the municipality. I've worked for processors, e-waste recyclers, and it's kind of when we look at lithium-ion batteries, it kind of affects us all. I mean, obviously a little bit more so for me now working for an EV manufacturer, but if you work for a waste hauler, I spend a lot of time creating outreach and education to try and make sure these batteries weren't getting into waste streams that they shouldn't, where they can create fires and things like that. And this is relevant for almost any recycler, processors, try to keep these materials out, create the education for it. And then also, if you're on the other side, if you're an e-waste recycler, you want to make sure none of those materials are going to landfill, because you want to secure that feedstock so you can have better processing and a greater return on your investments. So so now I'm kind of taking all that experience. I work at Lucid Motors, which is really exciting to kind of create these closed loop processes that, we often talk about, but don't always necessarily get put into practice. And I have a really strong backing from my employer. And the whole notion behind electric vehicles is the environment, right? So with that, you see a lot of major dedications from every OEM about what their environmental goals are. And for me, that's also very exciting because it creates a little bit of a competition within that shift in the industry to move to be more environmental. So kind of where we're at now, the current state as it regards to EV and recycling is that lithium-ion batteries affect many recycling streams. We had legislation in the 90s which kind of defined how automobiles should be recycled. And this largely had to do with all the hazardous materials that are contained in the car, so gas, oil, things like that. So when you're inbounding a car to get recycled, you have to go through numerous steps and reporting processes and accepting the materials, removing hazardous waste, dismantling the vehicles, and then storing the vehicle hulks. So it adds a few extra steps. What's kind of nice about the batteries, well, it will change. So a lot of these hazards will actually kind of go away, right? So less oil, no gas, but you'll have to deal with the battery pack itself. And so that will create some logistical challenges, but it will also create these new opportunities for subline, entrepreneurs that can possibly move into this space to either facilitate these transportation moves, or to actually do some of the labor to disassemble these packs or make sure they get to a second life back into that energy storage scenario, correct? But right now, a lot of that's still a few years away, so we have plenty of time to planning. But what's nice is that as we see this demand and we see these commitments, we're also seeing it from our federal government, which is nice, because when you get that further guidance and it starts trickling itself down, I think it will help align everybody kind of in the process, and then also add more strength to it. So you might have seen last week, Biden said that he set targets for EV to be at 50% by 2030. So that's great. So that's saying the administration is both going to boost electric vehicle demand and then trying to incentivize the domestic supply chain. So that's really the goal here. Instead of having such a linear movement to these materials, right? We're moving to a closed loop, and we have the full support from all the stakeholders we need to make sure we have a successful program. So lithium-ion batteries, obviously, is the demand is getting massive, right, on the metals, on the raw materials. So we can see here that in the next 10 years or so, that demand is only going to become greater, and that's going to strain the current markets. And so what we're seeing in like the EU, for example, is some of these market development tools where they're going to require 25% in lithium-ion batteries for EV vehicles by 2025, and then even 70% by 2030 for EV manufacturers. So with this market development, you can kind of see the connection of the importance that recycling is going to be. Right? So you have this high demand, but you don't have enough raw materials, or you have a lack of resources to mine these. So it's going to put that greater importance on recycling. But traditional recycling practices probably won't get us there. Obviously, pretty straightforward in recycling. Anytime you recycle something, you're going to downgrade the materials as you do so. So what we'll need in order to make this model work is advanced recycling. And we've already seen a lot of it in this lithium-ion battery recycling space, which is co-extraction and co-precipitation. So instead of shredding and smelting, now we have this advanced recycling process that is renewing the raw materials at a higher quality, where then they can go back into a high-quality product. And that's fantastic for everybody, right? I think it will encourage more participation, and with that, we'll kind of see the U.S. probably make more moves to that, saying what recycled materials from used batteries will meet a significant portion of that new demand in the future, and create a more stable domestic source for materials and battery production. And then you might have also seen earlier this year, about February to June, the National Blueprint for Lithium-Ion Battery Recycling, and it goes over just that. So it's trying to foster the design for battery packs to ease second use and recycling, establish successful methods for collecting and sorting transportation and processing recycled batteries, increasing recovery rates for key materials such as cobalt, lithium, nickel, and graphite, develop processing technologies to reintroduce these materials into the supply chain, develop methodologies for proper sorting, testing, and balancing for second use applications, and establish federal recycling policies to promote collection, reuse, and the recycling of lithium-ion batteries. And those are just the short-term goals. And their long-term goals are to create the incentives for achieving 90% recycling consumer electronics, EV, and grid storage, and develop federal policies requiring the use of recycled materials in cell manufacturing material streams. So again, it's one of those things where whenever you're looking to create these recycling programs, we always see some kind of a strain, or we don't have every stakeholder fully aligned to make these programs stand alone on themselves to be successful. But I think we're seeing all those pieces come together. And furthermore, as EV and AI increase in automotive, so this is the next 30, 40 years, I think it could ultimately change the way we conceptualize cars as we do today. So obviously, if you have AI driving a car and you've removed the human element, well, it completely changes the design. So right now, the challenge with recycling and car recycling is that there's, about 200 different kinds of plastics that go into making a car. And a lot of these plastics are needed to lightweight the vehicle, to make it safer, because inevitably people do crash cars. But if you're able to remove that human element and we go to more of a AI-driven mobility, well, you can kind of remove some of those aspects or change the complete layout of the car. And I think with that too, when you kind of move to that model, it will change the resources, but then ultimately the end of life. So it'll make it a lot easier to design for that recyclability and have a more closed loop model for cars as mobility increases. Again, you already see so many design implementations from every manufacturer to use different sustainable materials, different sustainable technologies, and things like that. And I think right now is really just the beginning of how all this is going to evolve. And it will truly come into fruition over the next 20, 30 years. But I think the catalyst is now. So it's really exciting, and it leaves a lot of opportunity for the recycling industry. Again, I think this will strengthen a lot of industries just in around reuse, repair, and things like that for these other energy storages. And again, it's just generally exciting to kind of see these two worlds come together. So in closing, we've kind of gone over the changes that we'll kind of see in the current state for how things are recycled, the need in the supply chain for recycling, for these advanced recycling practices, and to not only just for lithium-ion batteries, but also advanced recycling processes for other materials that go into making car plastics and things like that. Market development, getting more guidance for outreach and education, diversion goals, or recycled content goals are always great. And then just how this will change the design of cars in general, and how we conceptualize how cars are built, designed and the materials that go into it. So that's about it for me. And I'll look forward to any feedback.
Thank you, Brett. Brett, are you able to hang online with us for questions, or do you want us to go ahead and ask questions now?
You can ask questions now, yeah.
Okay, do we have any questions online? No, no questions online. What about the audience? Any questions for Brett? Okay, go ahead, Dave.
Hey, Brent, can you hear me?
Yes.
So I had a question for you. So through the supply, when you start looking at the supply chain, I mean, is it mainly, is nickel the limiting factor? And I saw China was buying up a lot of the world's nickel mines. Is that really the concern here when we're talking about lithium ion, or is it the lithium itself? Or I wonder if you could talk through that.
Yeah, I mean, it gets really complicated when you start getting into battery chemistries. And that's normally, so you'll actually, today, you'll see a lot of communication between recyclers and suppliers, or the manufacturers and the recyclers, because that chemistry is so highly guarded. But it's a combination amongst those materials. And that's kind of where the nitty gritty is. And that's what's at stake there. But it is a combination between all those materials that are going to be heavily impacted, and without the proper combination of each element, you're not going to be able to make a battery that meets the needs.
Awesome. Other questions? Okay, well, thank you, Brett. Maybe we'll have some questions pop up in the next few minutes as our next speaker joins us. So our third speaker today is Bob Huffer. He's the Eastern Regional Manager for General Kinematics, and he will be talking about industrial trends during turbulent times. So welcome, Bob.
Thank you very much. Thanks, Gene, for letting me step in here, fill in for one of the other speakers. I think they're pulling up my presentation now. Give them just a minute. I'll introduce myself as we're waiting. Again, as Karen said, Bob Huffer from General Kinematics. General Kinematics is a vibratory process company. We do design, engineer, manufacture, and install much of our equipment, as well as some of the systems. We're now promoting some of our system work that we're doing in various market spaces. So I think they're pulling it up here a second. Looks like they got it. There it is. Great. Thank you, guys. Yeah, like I said, General Kinematics, Bob Huffer, that's me. What you see there is just a couple pictures of some recent installations that were done here in South Florida, handling construction demolition materials. And that's been one of our larger areas that we've been focusing on, is construction demolition. Here in South Florida, that's been a very strong market. A little bit about General Kinematics again. We've got a global presence here in the U.S., also in Europe, Asia, Canada, South America as well. We do serve into many different industries, which I'll touch on a couple here that I think are kind of coming into play as that would be of interest to this group here, focusing on just some of the different trends that are happening out there. For myself, been with the company for 27 years, worked within our service group for a while, designing in the engineering side for a bit, and then now in our technical solutions group. And based here in Southwest Florida, near the Fort Myers area. Let me go back one. So had the fortunate opportunity to get out earlier this year and attend a couple of conferences, one of which was the Waste Expo, and I just flashed up the, yeah, thank you, just flashed up the one little graphic that they put up in the start of the show, which was kind of cool because it just, I think it captures some of the different thoughts and feelings of things that are going on in the recycling market space right now. So those who haven't been to the Waste Expo, kind of neat to see some of those. But that was back in June, and that show was, I'd say, about roughly half attended of what maybe normal attendance is between exhibitors and participants. But I think some of the people that were there were certainly focused on being in the right place at the right time for the recycling market. One more. Oop, there it goes. Sorry about that. So just some of the basic trends, and I'm probably not saying too much that a lot of this audience may not know, but just wanted to highlight some of them. In particular to us, some of the machines that we build are actually very big and robust and heavy. Some machines can be 80, 90,000 pounds. But one of the bigger issues that's out in the manufacturing side right now is obviously steel. Steel, from the availability of it, from the cost of it, as well as the controls, electronics, some of the building materials in wood, the new electronic chip issue in new cars. For that reason, rental cars are next to impossible to get right now, or you're paying 3 times what you normally would. New homes are behind in schedule, about twice about what they normally are. And the job market for those that are trying to hire right now are sometimes a bit of a challenge or hard to get. At least for us, that's what we're finding. Some of the hot markets are just the inverse to that. The used car market is, exploding. If you got a used car right now, great time to sell it. The real estate market, and money's cheap right now to borrow, so we're starting to see some people having good investments out there for capital purchases. In the job market, for those that are seeking jobs right now, it's actually one of the hottest times. So it's kind of a mix of things that are going on right now. But some of the other customer trends we're seeing is the lack of skilled labor that's out there. Myself coming from some of the service group area, I can tell you there's more and more less educated people that are running both maintenance and operation at these different facilities, and that's a big challenge. How do you promote your uptime and availability of equipment that everybody's forecasting to be very high when you don't have the staff to try to keep that up and maintain it? So we've been focusing a lot on the education, the maintenance of operations, and those operators for that reason, which I think has helped build more credibility with us and our equipment. I know other manufacturers have focused on that as well. And we've also integrated the ability to support some of that equipment remotely. I'm sure you've seen some of the little, we haven't gone this far ourselves, but I've seen it where they got the little video cameras on the hard hats and they're staring into a control panel. Somebody in, North Carolina is telling a guy on the West Coast how to fix something. Again, we haven't gone that far, but we certainly have gone to the remote support side of it. So some of the equipment we're providing, we can have, basically signals back to our offices in Chicago from Florida, let's say. They can tell the machine how it's running, how, if there's a problem, if there's an alarm that goes off, we can help work with an operator, tell them how to reset it, how to fix it. All those areas really play into, the operations and the maintenance of the equipment, which I think is really important. And it also, I think, also tells a little bit about where our workforce is going, as we're working with some of our customers right now. Some of the large investments we've seen, this is kind of the exciting time of it as well. Charlotte Pipe and Foundry, who's a 100-plus-year-old operation right there in downtown Charlotte's building a brand new greenfield foundry operation, shutting down their existing operation, which is right downtown. And that's a major project. We haven't seen a project that big in the foundry industry in several years. Nucor's investing. They've built a brand new steel mill here in Frostproof, Florida, which is kind of a secret project, but not so secret. Also, some of the North Carolina operations have been investing. Inland Steel is another great example. Burns Harbor facility in Indiana, that was changed ownership several times, but they've actually shut down, mothballed the steel mill for a period of time before Cleveland Cliffs picked it up. But all these are just trends of what's happening, right? The domestic markets right now are in high demand of steel, so other suppliers are starting to see this, and they're responding to it, trying to figure out how to get more domestic materials and meeting the domestic demand that's here in the U.S. Oh, sorry, went the wrong way. So I mentioned General Kinematics gets involved in a lot of different industries. Those that you can see kind of highlighted across that resource recovery header up on top. The couple that are highlighted in blue are the three that I was just going to focus on here that I think would be kind of pertinent to this group, that everything that I've been hearing and participated in the past for these types of conferences. So this was another conference we attended earlier than Waste Expo. This was the CDRA down in Austin, Texas, and very specific to construction demolitions materials, but I thought it was some interesting points that Bill Turley made at that conference. And the one was by weight, C&D material makes up the largest amount of the material waste stream in the U.S. by 583 million tons a year. And, you know, I don't know how many people are actually focused on C&D in this area, but if you're not, you know, it's an area that I know we've had a lot of different discussions with in the past, and with different groups, different people, both on the private side and the public side. Secondary to that point about the highest volume is currently it's also running at the highest recycling rate too, at the 73%. So I think that area has shown some really good growth, some really good technology improvements, things like that over time that's helped grow some of those numbers and address some of that waste stream. Let's see if I can, oh yeah, here we go, okay. So just wanted to point out this, I'm just throwing up a kind of a 3D image of a typical C&D waste stream. I just wanted to point out a couple kind of key areas. So I'm just labeling A, B, C, D down on the bottom of the screen there. You can kind of point them out, but at the start of this process, typically we start out with what we call a primary finger screen. That would be loaded with, it could be loaded a couple different ways. You could have an inclined belt feed, but in this particular case, your excavator loaded and or grapple loaded right into the vibratory machine. From there, that stream gets split into two different waste streams. One is what we call an A line, and then a secondary B line, which is the smaller material. So the primary screen typically makes a separation of, let's say, 8 inches in material size. The plus 8-inch material goes up onto this sorting table, which is done manual sort there, and they're sorting by wood, cardboard, aggregate materials, typically separating some of the ferrous metals versus the non-ferrous metals, and some of the plastics. The -8 material runs under an electromagnet, and then onto a secondary screen, which we remove the RSM or the fines, and then there's an opportunity there for some secondary sorting if they want it or not. And then finally, an air knife destoner, which is a density separator, which also separates the rock from the other materials. So I just wanted to kind of walk through that process. This particular operation is up and running and has been for a while here in South Florida and running close to about 1,000 ton a day type process. Just to give you an overview of that. So on the C&D side, we're seeing good investments, like I mentioned, both on the private side and the public sector. RSM is kind of an interesting topic across the board and everywhere. Specific to Florida, let's say, not too many people out of Florida know what RSM is, but it's basically recycled screening material. That's what that stands for, and it does vary in size based on location or based on facility. A lot of guys like to go small with it, so they can try to capture more of the rock out of it, get more of the heavy material and the aggregate out of it, so you're not sending that to a landfill, not paying a tip fee, adding it to your rock pile, which has a little bit more benefit on the revenue side. But they're also always looking for good wood markets. One of the topics actually that came out of the CDRA conference there in Austin, Texas, was some of the discussions around biochar, and that seemed to be a kind of a hot topic. I don't know if you've heard of it or not, but there's some manufacturers out there now that are call it a controlled burn process within a fixed chamber with minimal emissions, and it's basically just eliminating the wood into a char material, and then that char material turns into a kind of a secondary soil benefit usage material that is a marketable material. So, not going to go into great depth or detail, but if you Google biochar, you'll see what that is, and you could check it out. So I mentioned some of the air density separation machines. This is just kind of the family of some of the different machines that we offer. This is a separation process that's done by air. It's not a wet process. A lot of the years ago, when they were trying to do a separation for heavy to light material, they would use a float tank, which utilizes water. Water makes everything wet and heavy and is very messy. That's gone away, thank God, for most of the facilities we deal in. So now it's all utilizing air, which keeps the material dry. It's just a more environmentally friendly option to go as well. But so the air acts to separate that heavy material to light fraction, which is primarily, again, here, I'll just say here in South Florida, is primarily a lot of your rock, your aggregated stone, your tile roofing, even your tile flooring. All that goes, for the most part, into the same collection point, which is ground and then utilized as secondary suppliers. This just talks a little bit about the vibratory primary screenings we're offering that now can be utilized also in some of the lighter material streams. So we've had some material streams now, some customers that have also been utilizing it in some class 3 materials, and we've also incorporated into some of the single stream materials as well. Separating, just doing a raw separation and material sizing. On the single stream side, we've been utilizing it a little bit to separate the fiber from some of the other fiber OCC from some of the other container shaped materials. MSW, we've also been utilizing some of the vibratory screens for MSW streams, which there's not a whole lot of MSW processing facilities, but this was one that each one of those lines was running 50 ton an hour, so a 100 ton an hour operation altogether. At the time, this is no longer in operation, but at the time it was running. We're still working with a couple groups, a couple companies that are still looking down the MSW stream and how to pull out the recyclable content out of some of those materials, even as dirty as some of that material is or can be. Yeah, talked about some of those dual stream processes. What you see over on the left side is actually some of the other developments in some of the deck designs we've had, rather than just what we call steel fingers. We've also gone to some of these rod deck, which has also helped on some of the finer screens. So I'm going to shift now out of kind of the C&D side and talk a little bit about the waste to energy. And this, I've seen this picture, or this kind of cartoony picture a couple times, and if I just saw it probably 2 months ago in one of the Covanta plant manager's office, so I had to snap a picture of it and told him I was going to use it next opportunity, so I wanted to share it. But it's kind of a comical little sketch on, you know, how a waste to energy process works with, you know, some of the, if you're not familiar with waste to energy, but some of your raw material, MSW, comes in, goes into a tip floor, grapple loaded, basically into the boiler. The boiler, after all these guys that are stoking it, comes down, and out the bottom comes ash with metals. Throughout that heat process, all that steam goes up to turn a turbine, which, there we are, okay. Turns the turbine drives a generator, creates electricity. And that's the basis of it, right? So a couple of the two big players that are in this space here in the US, well, let me back up and just say, so the waste energy market, I would say 30 to 35 years ago, there was a number of different plants that were built and put into production, owned and operated by different companies over time, but roughly about 50 or 60 plants were built in a period of about 5 years. Those same plants are the same plants that are out there in service and running today. So a lot of them are in a condition where they need to be renovated or, you know, invested to help keep up and running at the level they need to be. So Covanta is one of the two big players that owns a number of these different facilities. They were just recently announcement where they've got an investment coming from EQT that's making an acquisition of Covanta. So that's kind of exciting news because Covanta was not in a very strong financial position here for the last couple of years. As you know, with some of the waste stream that's happening on the energy side, they weren't making a lot of money on the energy side and or the tip fees because they were locked into long-term contracts. The only area they were making money was on the metal recovery side and selling the metals, which fortunately the metals have been obviously a strong revenue side for them. So with all that said, everybody I've talked to at the different levels of Covanta, they all view this as a positive thing, and hopefully it's going to infuse some money into their group that's going to help drive and continue to operate these facilities long term. So the other comment I made here that actually is the next slide. So the other second partner is Wheelabrator, who is now Wind Waste as of about 1 or 2 years ago. Wind Waste has also made an acquisition to take over all those operations. That's a group that's also kind of refocused all their efforts. They've sold off all their European divisions that they had, now focusing strictly on just U.S. operations. And within the last short 1 or 2 years that it's been Wind Waste, they've had roughly 10 or 15 acquisitions themselves, buying up mainly in the Northeast, a portfolio of companies that are both transportation, collection, transportation, some C&D, but other processing, other transfer stations. So their goal is basically to take everything right from curb to waste energy facility. They want to control that entire process, and they're trying to create that model up in the Northeast. So it's kind of interesting to see how some of these different companies are refocusing some of their efforts and some of their structure and how they're going to market. So in the waste energy process, just to touch on, as the material comes out of the bottom of the boilers, they typically go into what they call an ash processing building or facility or one part of the plant. That's where the metals start to get separated. So typically they go from a primary screening area over to a secondary screening area. I skipped one of the steps here in between. There's your drum magnet. So they're pulling out the ferrous metals, secondary screening, and then to an ECS. So fairly straightforward, but you're collecting ferrous metals, non-ferrous metals, and you've got your ash, which is typically a combined ash of both fly ash and bottom ash. This is just a picture of what it looks like over on the left, that coming out of the boilers, and those are typically long vibratory machines that would collect all that material and then send it up to the boiler areas, and that would be one of the larger grizzly screens that starts to do some of the bigger size separation. Okay, shifting gears one more time. So this is kind of the last topic, just talking about third industry. So this would be the auto shredding industry. So in the metal side, you've got, in this particular case, you can see grapple loaded over to the right, dropping right into the mouth of a big shredder, and then you've got all the downstream equipment that is the ferrous, non-ferrous separation processes, and that goes into several different levels depending upon the operation. But this is probably one of the areas that's been impacted the most. And talking about commodities, every one of these recycling operations that we deal with, everybody's dealing in a commodity in one way or another. These were just some of the excerpts I kind of took out of the Construction Demolition Recycling magazine, which they publish every month or so in the new publication. But you can see where the ferrous pricing is, where the non-ferrous pricing is, the copper and aluminum. I mean, everything is basically twice what it was almost a year ago. And I mean, that's driving markets, that's driving investments, that's driving a lot. Also, obviously, the scrap producers that are feeding into these market spaces, and then those that need the scrap. It's all that trickle-down effect that's happening right now. So on the scrap side, this was another, I think this came from one of the other publications, it's an older one. I haven't seen a newer one published yet, but just talking about where some of the shred yards are located. And these could be some smaller operations, but they're all, for the most part, larger metal shredding operations. And typically in the metal shred areas, you've got smaller feeder facilities that'll feed into bigger, what we call mega shredder operations too. So in the metal recovery side, this is just walking through the process a little bit again, but you've got the metal shredder up on the top left. Typically, you've got a vibratory machine that takes that metals and materials away, going into drum magnet ferrous separations. You may have a secondary feed process here, going into some kind of air separation device, and then other secondary eddy currents or non-ferrous metal separations. These were just some of the photos of some of the different machines that were involved in that process. Yeah, I mean, the other big topic that has been within the last couple of years, before China stopped taking a lot of those metals and we're utilizing a lot of those metals here domestically, they couldn't get enough of these containers, overseas containers, and trying to get containers to load out with less than 10 minutes through an excavator. So that was another hot commodity for a while there, but has definitely cooled off since we're now utilizing a lot of our metals here domestically. So that kind of concluded what I had. I just wanted to give it from my perspective, which is from the manufacturing side, equipment provider, system provider, what we're seeing out there in some of the marketplaces and some of the trends that we're seeing in some of the different waste markets. So thank you.
Thank you. Let's give a round of applause to our speakers. So incidentally, C&D is the highest, has the highest recycling rate in the state of Florida also. So we're around 62%, and it's hovered there for quite a while. So appreciate all you're doing in South Florida to help that. Do we have any questions online that have come in for our speakers? Any questions online, virtual questions? Nothing's come in? Okay, well, we've had 3 great presentations, and again, focusing on some of our non-traditional recyclables. Any questions from our audience? Anything on C&D? Anything on battery recycling? Anything on waste to energy? And I know the plasma arc certainly has sparked my attention.
No pun intended.
Thank you. Just a quick question as a Hillsborough County resident in Tampa, which is McDill's base for Dave. With the recent project in North Florida and the estimate, I think I wrote the metric, you mentioned 5,000 to 6,000 tons a year. Is that correct?
That sounds about right. Yeah, for Hurlburt, yeah.
And the budget was 7.2 million.
It was.
So comparing that to McDill, do you have an idea of what the total tonnage is at McDill Air Force Base?
You know, just based on the head count between personnel and contractors, it might be 10 or 12,000. 10 or 12,000 tons per year.
Yeah.
But I'm going to let you finish your question, but I think I know where you're headed.
Well, go ahead. If you know where I'm headed.
So the interesting thing when we were designing, because we spent about 2 years designing that project, and we spent about 10 months building it. So we spent a lot of time thinking about the specific use at Hurlburt. And what we found is with plasma gasification, there's an exponential return on investment. In other words, what I'm trying to say is it's not a linear function, it's exponential. So when it comes to sizing a facility, just because you have twice as much volume, it doesn't turn it into a $14 million project. There's some economies of scale there because you're taking advantage of, you know, the thermal capacity of the crucible and different things like that. It's hard to put, you know, that project, shoehorn it into solving another project, you know, downstate. And what we've learned is the operational cost exceeded our expectations. Our CapEx was one thing, we kind of had an idea, and I mentioned, you know, we were over budget, which is typical for science projects, but the operational cost, as I mentioned, you know, when you're 3 times the prevailing tip fee at the landfill, the economics start to fall apart pretty quickly. In hindsight, because we were trying to solve a very specific function with a very specific waste stream, I mentioned there were 6, you know, waste streams that we were looking at. That wouldn't necessarily be the solution that I would recommend, you know, for like a project at McDill. You know, we are looking at projects for the Air Force, but I don't know that I would take that same project that we did at Hurlburt and recommend it for in this case, for McDill.
Is Hurlburt still operational?
No, so the Hurlburt project was really designed to be an R&D project. In fact, the state only gave us a 2-year permit. The idea was we were going to prove the case and share those results with the Pentagon and let the Pentagon decide what it wanted to do. The Navy stood up and said, we like that technology, which it was a vendor in Canada called Pyrogenesis, if you're curious. And the Navy commissioned 10 of those facilities.
Wow.
So, so it was designed to run through the extension or through the permit life, which was 2 years, and then that was it.
So with an ideal capacity of volume, say double what Hurlburt had, would that facility investment be able to handle, say, 10 to 15,000 tons a year or more? What would be the ideal feedstock to that facility, the one that you built?
Yeah, so Right now, there are so many technologies in the marketplace. You know, mechanical biological treatment probably makes the most sense. That project at McDill, partnering with the community, with Hillsborough County, for instance, or the city of Tampa, and building some kind of a regional solution probably makes more sense.
Which happens to be Covanta.
Yeah,
And
yeah.
Wheelabrator.
Yep,
So,
yep.
and the rate is more than what you mentioned earlier in Jackson County, so, okay, thank you.
Sure. Thanks for the question.
Other questions? Okay.
I have a question.
Dave has a question.
I got a two-part question. I'll see if I bring the panel and the panelists and the moderator here. And I hate to put you on the spot, but from a bottom ash, how much ash is actually, do you know how much ash is generated from a typical mass burn incineration between the fly ash and the bottom ash? I was just trying to get a percentage, if it's like 10% or 25%.
Yeah, I'd say the fly ash is probably in the 5% range.
Yeah.
Yeah. I mean, I know they also bring in, external
Right.
material as well as fly ash, so
Okay.
I think it's in the 5% or less.
And then my question for you, Karen, in Florida, can you use that bottom ash as alternative daily cover at the landfill?
That's a good question. I don't know. I would have to check with our solid waste permitting side of the shop
I was
because
just curious.
I'm not sitting in that side.
I know.
But there are some alternative daily covers that I do know. We do have glass used, and there are some yard waste type daily covers used, but as far as ash, I don't know.
Okay, I was just curious.
Yeah, I believe Covanta West Palm Beach has been doing some studies with, I don't know if it's Tim Townsend or others.
Yeah, it'd
to
probably
try
be Townsend.
Yeah, try to get into that.
Yeah, okay. Just seeing if there's a circular
A connection
economy
there.
loop that we can make. Yeah.
Okay, any other questions? All right, I think this leads us into the 5 o'clock reception in the exhibit hall. So 5 to 6:30. Thank you all. And tomorrow it looks like first session starts at 8:30 with a continental breakfast at 7:45. So thank you, everyone.